Hey, hello everyone. Welcome back to Cis Theta Learning, where system design becomes so easy, even your backend code stops throwing tantrums. So in the last video, we saw a single server setup, one lonely machine doing everything, like a college student, a night before the deadline. But now it's time to give the server a little help by adding database. Because storing everything in memory is fun until your server restarts and everything disappears faster than your weekend. So if you saw the last structure, right, we had this web browser or a mobile application, then in this a single server. Now I've just added database to it. First thing, so why do we need a database? Simple, your app needs to remember things: users, passwords, comments, memes, product orders, angry reviews, whatever you're building. So, and storing this on a RAM or as plain text, is it good? No, it's not scalable, not safe, not smart. So we bring in the database. So yeah, okay, let me take this. I think now the full picture is visible. So this is the database I've added. And when it comes to database, you have two types, right? The relational databases and the non-relational ones. So relational databases store data in tables. Okay, yeah. So they store data in tables like Excel sheets with rows and columns. You can define schemas, structures, set relationships between tables, and run powerful SQL queries. So okay, let's get some space here. Okay. So when it comes to relational databases, you have we can give example of MySQL, right, and Oracle database, Postgres or PostgreSQL. These are the examples. So what's relational database? You have tables, that is rows and columns. So these can be used when the data is structured and it has well-defined relationship and there is strong consistency and ACID compliance. So you have the SQL, that is query language. But it's not ideal when you have unstructured or constantly changing data. And if it's not good if you're if the because relational database is not good because it doesn't scale horizontally very well and can be slower when handling large scale read writes across huge data sets. So then comes the non-relational databases. So these are more chill like, okay, they store data as key value pairs, documents or graphs without rigid structure. So popular ones are example in non-relational would be we have you can just Google and read about them. Maybe you have this CouchDB, then you this Neo4j, then you have HBase, you have Amazon DynamoDB. There are many others. There's Cassandra. You can just Google. So this is great for unstructured or semi-structured data. It has high performance and low latency, easy to scale horizontally, flexible schema, can change over time. But cons may sacrifice consistency and limited query compared to SQL. So less strict structures. So and one more thing is join operations are generally not supported in non-relational databases. So for most developers, right? Okay. So for most developers, relational databases are the best option because they have been around for 40 years and historically they have worked well. However, if relational databases are not suitable for your specific use cases, it is critical to explore beyond relational databases. So non-relational databases might be a good choice when first your application requires low latency. So it requires low latency. So let me increase this. Yeah. So it requires low latency. So latency means the delay between a user request and the server response. So this is a user and this is a server, right? So user requests something, and so if it takes suppose it takes 3 seconds or maybe 0.01 second or 5 seconds. So so the latency means the delay between user request and server. So it should be low, right? The application, so you should get the response as soon as possible. So that is the delay. So that is low latency. Okay. Second one is your data is unstructured. Data is unstructured. then you can use a non-relational database. So these are, I'm giving you 4 points where non-relational database is a good choice. Next is you only need to serialize and deserialize data, right? Serialize and deserialize data. So serialization means converting your data into a format that can be stored or transmitted, maybe like JSON, XML. So these are the examples. And deserialization is turning it back into something your app can use. So let's take an example. Maybe if you didn't understand what is serialized, deserialized. Let's say you have a user object in code like this. Let's say user and key value case name. Let's keep it the legendary wrestler Randy Orton, right? And maybe you have another known as subscribe. It will be a boolean value, true. Then you'll have followers, right? Followers, maybe something what we say 120,000, something like this. I hope he has more million followers. So when you deserialize it to JSON, so what it becomes? So you'll not have this. Okay, maybe let me write it down. Let's avoid confusion. So when you deserialize, it will be like this: name, what is it, Randy Orton, subscribe, true, and followers. We have a number, right? 0. Okay, so this can be now stored in your let's say you have this was the object code, and when you serialize it to JSON, it becomes like this, right? When you serialize it to JSON, it becomes like this, and this can be now stored in your database, sent over the network, or even saved in a log file. Later, when you retrieve this JSON, you deserialize it back to a usable object in your code. It's like putting your lunch into a tiffin box. Putting your lunch into a tiffin box is serializing, and then unpacking it at work, it will be deserialized, right? This is the example. So this was the user object. Maybe if I said this was serialized in the beginning, I'm sorry, my apologies. This is the user object. Then this will be serializing, and then you will be deserializing. So best example is putting your lunch into a tiffin box. This will be serialized. Then unpacking it at work to eat it. This will be deserialized. So this is what I wanted to cover in this video. I hope you understood this. We saw four scenarios where we can use a non-relational database and relational database. I hope you are aware. When you are doing system design, you would have known the basics of computer science. So this is just, we added this database, right? We had a web server. In this we have added database. So recap, we added a database to a single server system, which we saw previous. We saw two types of database, that is relational and non-relational, and then we saw four scenarios where we can use non-relational database. So that's all I had in the video. Thanks for joining, and if you have any comments, if you want a more detailed explanation, please let me know in the comment section. And if you like this video, please subscribe and share this video. Thanks for joining. We'll meet you in the next video. In the next video, we'll speak about vertical scaling versus horizontal scaling.